Back to the channel. In today's video, we are going to walk through one of the most important beginner project for the DE1-SoC board, my first HPS FPGA. By the end of this video, you will understand how the ARM HPS talk to the FPGA fabric and how to add a PIO parallel input output component to the platform designer and how to map its address in C, and finally how to control the 10 LED from the Linux running on the ARM processor. So those are the hardware and tools requirement for this project. We'll need Intel Quartus Prime, and we'll need Intel embedded design software, and for sure we will need the board, and we will need USB thumb drive and micro SD memory card for Linux operating system. In the Altera SoC FPGA, the HPS and the FPGA fabric are connected through AXI bridges or AXI bridge. Those three bridges, and those bridges allows the ARM processor to access FPGA peripherals, or for the FPGA to access HPS memory. So we have three bridges: HPS to FPGA bridge, and we have lightweight HPS to FPGA bridge, and we have FPGA to HPS bridge. In this tutorial, the lightweight HPS to FPGA bridge is used to control the LED for the SoC board. So we begin starting with my first HPS FPGA project. So the project is consisting of two parts: the FPGA RTL part and the C part. We will start with the RTL part. This is the RTL project opened in Quartus. So we will need to open platform designer. So from tools, platform designer, it's the same, it's a QSys, platform QSys, they both are the same. So this is the platform designer opened, and to let the ARM control the LEDs on SoC board, we need to add parallel input output, which is PIO LED component. And in a platform designer search for this, for PIO, this is the PIO. And to be able to like add something, now we already add the component, but to be able to add a component, so you need to go to processor and peripherals, and from peripherals you will find parallel input output here, PIO. So we already added here. It's here, and we will need to do some setting here. So we will need to set the width to 10, which is 10-bit output register mapped to the LED pins. So since we have 10 LEDs, we need to control the 10 LEDs on the board. So we will make the width to 10, and we will put the direction as output, and the reset value to this number 3FF. So finish. And next, we will need to connect this parallel input output to the HPS. So now this is the this is the HPS to FPGA lightweight XC master bridge, and this is the component, the PIO LED component. So we will need to connect those together. So as we can see here, it's connected. Uh, this is the bridge that the ARM program will use to write the value from to the LED register. And if we go here to the address map, so this is the connection that we made from H2F lightweight XE master to the PIO LED S1. And we will set the base address to this 0, and in the same time we will need to export this signal to the top level design. And if we go to the top level design this and search for something SoC, so this is the signal is exported here, and as we can see here, it's parallel input output LED external connection export. So now after that uh, we can generate HDL. I'm gonna stop, pause the video. So after we connect the PIO slave port to the H2F lightweight XE master, so now we are ready to compile the project. So compile, and I'm gonna pause the video. It's gonna take a long time to be compiled. RTL compilation done. So now we have the SOF file generated. This is the SO file, which is the binary file and ready to be downloaded to the FPGA Cyclone. But before that, before downloading the SOF file to the FPGA fabric, we need to finish some steps on the C program compilation, because the VGA controller of the Cyclone of the Terasic board is lives in the FPGA fabric, not on the HPS. And if we download the SOF file now, we are wiping out and replacing everything that was previously running in the FPGA, including the VGA hardware. And because we need the FPGA VGA monitor to run the C program Linux terminal now, so we're gonna keep it as is now and go to the C part of the project. So this is the C part of the project. This is the header file, and this is the make file, this is the main file. So this is the main file. So the goal is to write a C program running on Linux inside the HPS and control the LED through the memory map input output. So this is the main code. And in the program, op this open function is to here using this function mmap to map the physical address here of the parallel input output component into user space. So the address of the FPGA component as seen from the ARM processor can be calculated as the base address of the HPS to FPGA bridge plus the offset address on the platform designer. So to access to LED register connected to the this address, this address. So we need to add the HPS to FPGA lightweight H2F base address, which is here, plus the offset address of the platform designer. This is the HPS and this is the FPGA. So we need to add this to get the physical address to this register, which is here. And that will give you a pointer to the LED register. Here is the controlling of the LED. So this is LED mask, which tells which LED position is active. And those lights are active low. So if there's some, this is the initial value. So that's mean all the LEDs are on except the first one is off. Now the LED direction 0 from left to right and 1 from the opposite direction. And this is the loop here, and counts how many full back and forth cycle we have done. And here is the wait 0.1 second between steps, so the movement is visible. So now we need to compile this project. So we're gonna use ARM cross compiler provided by SoC EDS. We are in the directory of our C project. So we're gonna make to compile the code. And as we can see, we have the executable file generated, and it's ready to be uploaded to the SoC board. So we transfer the executable file here in this USB thumb drive, and we boot the Linux here. So we have the USB drive mounted to the Linux environment, and we have, this is our executable file, and it's ready to be run. But as we mentioned before, we need to download the RTL, the binary of the RTL part to the SoC first, and then we will just click enter on the Linux environment, so we can get both downloaded together. So after the RTL get compiled, it's ready to be downloaded to the FPGA board. So this is the, so we can change the file. This is the SOF file. We're gonna start downloading the file, and we're gonna lose the VGA monitor. Something wrong. So this is the Windows PC, and this is the Linux connected to the Terasic board. And here we can see it's ready, the C executable ready to run, and the SOF file ready to be uploaded. So as we gonna start uploading here, we're gonna lose the Linux VGA monitor. So we're gonna run it here, and as you can see here, it should count 60 times. Before it's terminated. "60 times back and forth." Okay, it's done.